things I'm going to show you today are mostly changes that have ended up in the browsers. And when the browsers change behavior to make it more secure, usually you need to also change the server accordingly to like pick up new information that are coming from the browsers or just instruct browsers to behave better. So since Go is starting to pick up some pace and being used as a server-side language for web applications, we thought, okay, let's take a look at the state of it and maybe try to make it better. We found out that most Go applications don't implement security correctly, at least some of the stuff that I'm going to talk about. So I was like, yeah, maybe let's just talk about it. Someone might find it interesting. And we are refreshing slides, and this is amazing because, you know, it's like I usually do that with web pages, and refreshing slides is a sentence that I was yet to hear. So you probably know what injections vulnerabilities are. It's like SQL injections, you've probably heard of them. It's basically you take a string, an untrusted string from the input, and that untrusted string somehow gets promoted to code. It's either SQL code or other things in your program. So let's take a look at this. This is using the database package in Go, the standard library one. And it's just HTTP handler taking stuff from the request, concatenating it to the query, and using it to run stuff on the DB. This is not a good practice. In case you have code like this, just refactor it, please. But I work in security in Google, and we can't really take a look at all the code that we have. It's kind of boring and a lot of code. So we try to make it a faster process to review code. The way we do it is usually relying on types. So we refactored the database package so that it's not visible. People cannot import it directly. They have to use a wrapper around it. And the way we make sure the queries are not composed at runtime, we just change the API to accept an unexported string type. The only way to implement that type or construct a new thing of that type is to have a string literal at compile time. Otherwise, there is no way to pass runtime values, because strings in Go can also be compile time strings, and they behave slightly differently, and this is the way to go. Pun not intended. So next thing is reflected and stored XSS. Who here has heard of XSS? Okay, that's good. So out of the many ways that we found that led to XSS in Go, one of the major ones were to have text template imported by mistake, because you're so used to Go import, and you love Go import, and you trust it to do the right thing. So you just type the template, run it, you imported text that doesn't do any escaping, doesn't do any sanitization, so you end up showing code to the users instead of data. Another very common mistake is to write directly to the HTTP writer, and that doesn't do any escaping. So for example, in the example below, if you do not apply any additional sanitization, you're going to output errors to the user, and they might contain user-controlled data. This leads to client-side code execution. For example, if someone picks that as a username. So if you have code like that in the front end, and in the back end, you interpolate that string, that is going to add a new thing to the DOM, run the malicious stuff, and your user data is gone. So the way to fix it is usually to restrict visibility on text template, which is horrible because sometimes you need text template. We are developing a new package that is going to be open sourced very soon. Trademark symbol here. This should land in a reasonable amount of time. And the other way to fix it is to never make mistakes, which is easy, right? I mean, who does that? Why would you do mistakes? So if you do mistakes, if you make mistakes, you should probably have a content security policy set up on your server. Content security policy is a header. It's the thing on the left. That header says, a lot of things, but the most important one is like script source, nonce, and then a safe random that you generate every time you render a page together with a template. That instructs the browser to never execute a script unless the content of the page and the nonce value matches the header. So if an attacker is able to inject some code, even HTML code, arbitrary HTML code, that will not execute because they cannot guess that value. So if you look at it on the right, the nonce is unguessable. So even if you inject any of those things below, that the browser is just going to throw an exception. And that is good, but it had some problems. Those problems were, what if you import a script and that creates a script tag in the page that will break? And turns out people use that feature in browsers because reasons. So we came out with this solution. So there is strict dynamic in all browsers except Safari that allows you to promote a script to trusted. So if it does add a new script to the page, that will be trusted too. If Safari is rendering this, they will not understand strict dynamic, so they will skip to the next directives, which are unsafe inline HTTPS. So they will default to no policy. Basically, any script over HTTPS will work. So they won't get the protection, but everyone else will, which still a win, I think. So we are designing a package to make it easy for you to interpolate nonces where needed. So this is the proposed API that I had internally. So basically, you nonce the template when you before parsing it, and then on your handler, you do CSP protect. That will take care of injecting nonces and do everything you need. And so when you execute the template, you can do just execute context, and the value will be there. But execute does not accept a context yet. So I've linked to the proposal. If you think that would be useful, please add more use cases to it. Maybe we can push it there. Otherwise, it will become a little bit clunkier, but still, we're going to push a package to ease the process. So, DOM XSS. When you write Go, you're in the backend, and you have types, and you have all the nice things that we love about Go. When you write frontend, DOM XSS basically happens when the server has no clue what is going on. This is completely client-side. You're setting stuff in inner HTML with a location hash that is not even sent to the server. And that will run, because why not? So that thing will trigger client-side execution without the server knowing. So if the server is not involved, how do you fix it? Well, you don't. So there are many things that could go wrong. Those are just some of the strings that you can set and assign to that will lead to somehow XSS or bad behaviors. This is just some because I was out of space. So this was kind of getting messy, so we decided to do something amazing. Try to fix it, got it wrong many times, so we decided, what if we did something different? What if we changed the platform by adding types to JavaScript? And that's what we did. So JavaScript has now typed DOM APIs. So you can take a string, which is just a string, and promote it and say, this is actually HTML. And that is the only thing you can assign to an HTML DOM element. If you try to assign anything else, like a bare string, that will throw an exception, not execute. And to enable this feature, you just need to set a header. And this gives you type safety at runtime in the browser. So if you're used at like looking at stuff in Go and know nothing can go wrong, you can trust this. And you can have, for example, a default policy that takes any string as an input, sanitizes it, and says, this is safe HTML, I know because I sanitized it, so it can't really execute code. And this is an example. So I just try to set a string to inner HTML. That is the exception. This is already in Chrome, I think, beta or Canary, but it will land in stable soon. Just a header. Should be fairly trivial to do this server-side. So this is probably some lesser known vulnerability. How many of you know of XSSI? That's what I thought. And 2 months ago, I had no clue. So let's put it like that. It's not an XSS. Regards scripts. It's something cross-site. But it wouldn't be a web thing if it wasn't confusing. So let's say that you have dynamic scripting. This is very common. You see a request coming in, and you take the cookies, and based on that, you change the response. So like you interpolate stuff in JavaScript, like the script on the left, or you do JSON-P. So you wrap the JSON in a function call, and that is dynamic scripting. A lot of people rely on that, and that is good. Except the browsers have no idea when to send the cookies. So if evil.com sources your dynamic scripts cross-site, the browser will attach the cookies to the request. So you will render the JSON server-side with the user data, and evil.com will be able to read it. This was not exactly nice. So we thought, how can we fix this? So what if we added an infinite loop at the beginning? So if you source it same origin, you can always take the content, strip the first 8 characters, and eval it, which is bad on so many levels, but this is how we're doing it nowadays. And please, if you implement this in your service, don't do while one or throw stuff, because in JavaScript you can, for example, change the constructor for numbers and make one become falsy. This is just syntactic tokens, so it's probably not gonna bite you. So this, of course, doesn't look right. And at this point, we're like, the user agent, the browser, is not cooperating with the users. It's not trying to protect them enough. So what if we make the user agent actually the agent of the users? Give the server information to how to protect them. This is what we did. We added 3 headers that are going to be attached to every request that basically tell the server how this data is going to be used and how is this being sourced. And I have an example here. So if I'm fetching this script, Crosssite, the server will see segfetch mode, no course, because the scripts don't need course headers to be fetched Crosssite. Segfetch site, Crosssite. So the server is going to be, do I need this script to be sourced Crosssite? Probably not. So let's just respond with a 403 or a 500 or a Y, because at the point, does it really matter? This is the entire server-side logic to protect against XSSI, cross-site request forgery, and many other attacks that are nowadays in the platform. And they will go away if you just do this. So the logic is parse the headers. If there is no site header, the browser doesn't support this feature. Let's just allow it. Let's just use the old methods. If there is none, it means that the user decided to visit this site. It's like they pasted a URL in the browser or they clicked on a bookmark. This is fine. The user intended to do this. If it is same site or same origin, I'm doing it, so it's probably fine. But then, if we fall in the second if, we are cross-site, we are in dangerous land. So we just allow get navigations. Everything else will be blocked. So we know that the user will only land on a page if they navigate there. You don't need to implement exactly this logic. This is what I implemented in that module that you can just import and use right away. There is also a report-only mode that will just log the request that you would block without changing the logic. But for example, let's say that you're a bank, any bank, and you want to make sure that the authenticated part of your website does not act by just visiting it, but if you come cross-site, it will show you a page saying, hey, you're trying to make a transaction here? Is that what you intended to do? But only if you come cross-site, because you don't want to destroy user experience. You can change the return true, or you can change the signature of this function to just do a redirect to a prompt page. This is very easy to do server-side, and this is why we like this spec, not just because we came up with it. So, yeah. So, lots of stuff gets blocked with this logic, and I suggest you to try it out. It's going to land soon in Chrome and is already implemented in Chrome Canary and Chrome Beta. So let's just give it a shot. If you thought I was done, I'm not. There is cross-site search. Who has heard of this one? Yep. It's not commonly known, but almost all applications that we tested were vulnerable to this. In 2016, it was possible to leak your credit card information from Gmail in less than a minute. So this was scary. We started tweaking, changing the code in all our code bases. We have a VRP program, so if you find a vulnerability in Google services, you can report it to us, we will pay you for the report. And at a certain point, we had so many of those, we had to like tell hackers, okay, we got this, please stop. We're trying, okay, stop. So at this point, we're like, what if we did something better than just hacking something in every application we find? This is the logic. Evil.com opens a window to victim.com, and they can, because browsers. So then they navigate that page many times to different search things. It's like searching in YouTube, searching in Gmail. They can change the URL, and they can see how much time it takes to load. So if you have 0 emails that match, for example, 4 digits, that is going to be a quick response. If you have many emails that match those 4 digits, it's probably going to be a slow one. That means that you can also actually find the quadruplets of your credit cards. And once you have all of 4 of them, you have 12 just attempts to find the actual credit card. When I saw this, I was starting to cry, because how do you even protect from this server side? Well, there are ways to protect against this. It's not easy, hence the crying gopher. This was my attempt to have pictures. So we started adding CSRF tokens to every request and response. It was good, it worked, except people were like clicking on bookmarks, and they found out they stopped working. Because of course, users bookmarked search things. And so we went back to designing browsers, and this actually came, I think, from a Firefox engineer who said, what if we change the behavior so that if you open a window, and that window says, you're not allowed to open a cross-origin window, or if you navigate to a different origin, that origin says, if you navigate to me, break the context. No one is able to navigate me. And this is how it works. You just set a header, cross-origin opener policy. Yes, we love acronyms. They all look the same. Same origin. That means if someone opens a window to you cross-origin, they can, but when they try to change something about it, they will get a closed window reference, not the actual one. If they navigate to you, if they then navigate back, there will be no history API to check, no frame reference. This is just like opening a new tab every time you navigate cross-origin. This is still undergoing some design. I would suggest you to try it. It's in Firefox Nightly. If it doesn't work as you expect, please let us know. There are public issues on GitHub that you can use, open new issues on the spec. That is good, and it will help us understand what is the main pain point with this. Especially, we are aware that there is no reporting API. So if your application has some windows that must work cross-origin, maybe don't use this yet, because you might end up breaking stuff without noticing. So this was the end of the slide. You can find slides there. And I wanted to, since I am not connected anymore, I need to go back to the slide with the code, I guess. Yes. How do I switch back to my laptop? I guess. Okay. Why did it start working? Okay. So these is the entire code that the package that I showed you before for the secfetch part. I expose an API that allows you to protect an entire handler. And thanks to Go being designed in an amazing way, a server MOOCs is actually it's actually a handler. So when you protect it, the entire code that you need to use is like this part of the documentation. So what you do is take your server, take your exact code as it is, and you just do secfetch protect handler. That's it. And you're not vulnerable from many kind of attacks. And at this point, I was designing this API and I thought, what if someone wants to allow some coarse endpoints to still keep working? This will break all of them. So turns out you can compose HTTP handlers and decorate them. So what you can do is just do a thing that I have, I think, in tests. Basically, you take a handler that you protect, and then you take a handler that you don't protect, stuff that you want to still keep working cross-site. And then the way you compose it is just, actually, that's it. Yeah, because if you protect the handler and you just handle slash with that on the MOOCs, and then you add another path that you're handling, that is going to default to the first part for everything except for the last one that you set up. So just if you have a chain of handlers, which is probably the pattern that you're going to have more likely in your code, if you have a chain of handlers, you can just say, okay, so let's just protect everything up until a certain point. Then you have the protect call, and everything that comes in later, so all the handlers you register afterwards, are going to keep working. The report-only API is very trivial. You just give it a logger that has a log request method for an HTTP request. And that part is just going to do everything that it was doing normally, won't block anything, it will just pass you the request. This allows you to decide what to do. One example you could implement is like some here. It's cross-site get navigation. I don't want the user to be pwned in any ways. So even if it is just a get, maybe it's changing state. So you have access to the request here, and you can do like cookie. And you could add, for example, a default cookie that your server will recognize, and you will overwrite the current cookie of the user, and your server will recognize this cookie to be not something to act upon. The next request that comes in from the user will be same site because they are now on your page. So the right cookie will be sent. This will not interact with the request flow. And so you will be able to just not change anything else. So the prompt page that I was referring to before is just, you can cross-site, or you want to make this transaction, will only show on the first navigations, not on the following ones. And I found this quite powerful because you use the composition of HTTP handlers in Go and just the fact that you still have a reference to the request before it gets acted upon to protect your users. And if you have sensitive data, it's probably what you should strive to do. And that was it. I'm going to go to the last slide. And thank you. So we should still have 5 minutes if I counted correctly.
Yeah. Yes. Any questions?
Wow.
That's all right.
Hey, so on that last timing attack for the search part,
yes.
Would you say that, could you detect on the browser side if it's a cross-server request, add random sleep to the request so that it it's not so deterministic, the time that
Nice.
it takes.
We try to fix it that way by adding random slips if it came cross-site, stuff like that. Cool, but we also find out that hackers were using caches. So I do a cross-search browsing, and then I check if a resource is in cache. If it is in cache, maybe it was already there. So what you do, if you change the referrer to an incredibly long referrer, and then you visit that resource again, the server is going to say, this header is too long, 500, so you clear the cache. And then you visit, yes, it's amazing, I love browsers. So yes, if you sent a header that was too big, the service would normally reply a request too long. That purges the cache for that resource. So then you navigate to the page again, and you try to read it again. Is it in cache? Yes, then you know. And Twitter was vulnerable to this for the profile page. So if you wanted to identify a user, you created like 1,000 users. Each one of those blocked a different set of accounts. Mm-hmm. Then you navigated the thing, and you checked which profile picture would be in cache and which not. That gave you like bits of entropy anytime. So in like 12 requests, you could identify anyone in the globe.
Okay, thanks.
What do you think? Yeah. I love this stuff. That's not a microphone.
Hello? Yeah?
Oh, is that? What? Okay.
Yeah, it's great. Thank you for the talk. I was wondering, you were talking a lot about supporting Chrome, but how well supported is this in all the other browsers in the world?
So actually, very good, because the Crossorigin opener policy is already implemented in Firefox nightly. CSP with strict dynamic is in Firefox and Chrome. CSP without strict dynamic with nonce only is already supported in every browser that it makes sense to protect. Then there is trusted types are going to, they have been picked up not just by browsers, but also by frameworks. So if you use React, you will be able to just enable it. Like if you use Google Closure, I know no one uses that, but if you use Google Closure, you actually have already support, and so it's pretty well accepted. SecFetch is being discussed by Firefox engineers. I don't know the state of that, but they're just blocked on an approval, but they already have some trivial implementations. It's going well.
Thank you.
Hi, thanks for the talk. What use cases are currently in the way of making the cross-origin opener protection the default behavior?
So we thought about it, and then we saw how much of the internet would break. 4% was a high number. So no. Also, most OAuth endpoints would break. Yes. Yes. So actually, we are working on something slightly different, which is inheritance. So if you do just set somewhere cross-origin opener policy, same origin, and you open a page, same origin, that doesn't have the header, that in theory, in the first draft would break. Instead, now it inherits it. So that it says it's a same origin thing, so I can just use the previous co-op value and just inherit it. We found out that when you deploy stuff across several hundred cells across the globe, that comes in handy, because otherwise parts of the application would start to randomly break, and we don't have any reporting API. So I work in defense. I usually deploy stuff, and I like to know, okay, I'd like to not break stuff, but I also like to know when I break stuff. So yeah, we are working on making it easier to deploy. We don't really know how to right now.
Thank you.
Are there any more questions?
That's it.
Okay, 20 seconds.
Cool.
Okay.